Right, this first question is really typical. This could be a longer response question in the paper. So we need to have the correct name of the equipment. So a gold leaf electroscope. We charge it negatively. That's really important. If we charge this positively, then we wouldn't get an effect. So it must be electrons that are involved, that are removed from the metal. We must mention the zinc plate. That's important. We could also talk about this lack of effect of white light. That's quite significant. We need to mention the type of light, so it's UV light, and what it does. It makes the gold leaf foil fall back to the vertical. And then some kind of explanation. So we're giving energy to the electrons. The electrons then have enough energy to leave. So because we lose this excess of electrons, then the gold foil becomes discharged and falls back to the vertical. And the significance is to do with this idea of photons, particles of energy. So the energy of the photon is related to the frequency rather than the intensity. So we could make a reference to E equals HF. So question 2 is fairly straightforward. It's just calculate the energy. You could get a question as simple as these two in the exam. So E equals HF. Make sure you get the correct value of Planck constant. Make sure you're using this, you're putting the numbers into your calculator correctly. And you should expect a really tiny value. So if you get a large value, then you've made a mistake somewhere. So it should be 10 to the minus lots. 10 to the minus 13 sounds about right. Similarly, if we have the wavelength, so we've got hc over lambda, nanometers, obviously our prefix, 10 to the minus 9. And again, a really small value, that sounds about right. Question 3 is probably more likely what you'll get in the exam rather than question 2. So we've got a couple of things to do right at the start. So if we're given the frequency, we're trying to find the frequency, we're given the wavelength. Do remember that sometimes they won't tell you what the velocity is because they expect you to know the velocity of light is 3 times 10 to the 8. So they don't mention that in the question, but we do know that already. So we can calculate the frequency. It should be a very large number if it's visible light, monochromatic, single frequency. And then we can calculate the energy. So I've done this in 2 stages. If you wanted to do E is equal to hc over lambda, that would be absolutely fine. How many photons does the laser emit per second? Okay, so mathematically this is quite a straightforward calculation, but this can cause confusion, partly because, as we said before, there is no formula given for calculating the photons per second. So we've got the energy per second. Well, that's the power, which is 0.2 10 to the minus 3. We've just worked out the energy of a single photon, so we can calculate the number of photons per second. So again, if you can remember this formula, that's great, or you could look at the units, joules cancel, and we're left with s to the minus 1. And then if we increase the power, well, you could do a calculation, that would be fine, or we could just explain it. But we know that the power is going to be doubled because we're going to get twice the number of photons per second. So we don't get an increase in photon energy, we're just going to get more photons. So twice the power, twice the energy per second, therefore twice the number of photons